Assalamu alaikum and good day to Dr. Ko. My name is Muhammad Azhari Hassan. I am from Group 9 with my friend J. Muhammad Fajr, Nur Juliana, and Shash Meeta. We are going to present about production of cellulase. In this presentation, I will introduce our project on the production of cellulase using an industrial stirred tank bioreactor. Cellulase is an important industrial enzyme that hydrolyzes cellulose into fermentable sugar. Because of this function, it has many application industries such as bioethanol production, textile processing, food processing, pulp and paper manufacturing, and agricultural waste utilization. As the demand of sustainable industrial processes continues to increase, the need for cellulase production has also grown. In this project, cellulase is produced by trichodermaricide through aerobic fermentation. The fermentation takes place in the fed-batch stirred tank bioreactor, which provide the optimum condition for microbial growth and enzyme production. The microorganism selected for this project is trichodermaricide. This fungi is one of the most widely used microorganisms for industrial cellulase production because of its high enzyme productivity and genetic stability. It's also reliable for large-scale production and performs efficiency in stirred tank bioreactors. Since cellulase production is aerobic process, trichodermaricide requires a continuous oxygen supply, making it well suited for this type of reactor. For these reasons, trichodermaricide was selected as a production microorganism for our design. Bioreactor selection. The selected reactor is a stirred tank bioreactor. This reactor is commonly used in industrial biotechnology because it provides excellent mixing and efficient oxygen transfer. It also allows good control of temperature and pH, which are essential for maintaining microbial growth and maximizing cellulase production. The reactor operates in fed-batch mode. In fed-batch, fermentation nutrients are added gradually throughout the process. This helps prevent substrate inhibition and improve enzyme productivity. Overall, the stirred tank bioreactor provides a suitable environment for efficient cellulase production. Design basis. This slide summarizes the main design basis used for the bioreactor. The product of this process is cellulase, while the selected microorganism is trichodermaricide. A stirred tank reactor operating in fed-batch mode was selected with working volume of 100 meter cube. The fermentation temperature is maintained between 28 and 30 degrees, while the operating pH is controlled between 4.8 and 5.5. Finally, stainless steel was selected as the construction material because it provides excellent corrosion resistance, good mechanical strength, and maintains sterile operating conditions. This design condition ensures stable microbial growth and efficient enzyme production. Vessel volume calculation. The first step in the reactor design is calculating the total vessel volume. The working volume is assumed as 100 cubic meters. According to the design guidelines, the fermentation broth should occupy only 75% of the reactor volume, while the remaining 25% is left as headspace. The headspace is important because it provides sufficient space for aeration and foam formation during fermentation. Using the equation shown on the slide, the total volume is calculated as 133.3 cubic meters. This calculated volume becomes basis for calculating the reactor dimensions. After calculating the total reactor volume, the next step is to calculate the reactor dimension. Using the cylindrical vessel equation and height to diameter ratio of 3, the tank diameter is calculated as approximately 3.8 meters, while the tank height is 11.5 meters. Next is the impeller design. Based on the recommended design ratio between the tank diameter and impeller diameter, the impeller diameter is calculated to be approximately 1.3 meters. Because of the reactor has relatively large height, 3 impellers are selected to provide efficient mixing and improve oxygen transfer through the vessel. Finally, the baffle design. According to the design guidelines, the recommended baffle width between 0.2 and 3.8 meters. Therefore, a width of 0.35 meter was selected, together with 8 vertical buffles. These buffels prevent vortex formation, improve mixing efficiency, and increase oxygen transfer during fermentation. Overall, the selected vessel dimension, import design, and buffel arrangement provided efficient mixing and create suitable operating conditions for industrial cellulase production.
Thanks for Azhari for his part. Now let's talk about media formulation part. In this part, we will talk about the media formulation for the production of cellulase. Now let's look at the table. We have component, typical concentration in gram per liter, and amount for our working volume, which is 100 meter cube, and also the function for each component. So the first one is lactose. Lactose we use about 2000 kilogram for our working volume as our main carbon source and also a cellulase inducer. And also we put ammonium sulfate as nitrogen source. We also add phosphate buffer KH2PO4, and also we put magnesium sulfide as a cofactor for enzyme in the microbe so that it can produce our desired product effectively. And also for calcium chloride we add to stabilize cell wall and enzyme for the microbe itself. Furthermore, we use trace element. This trace element is for the essential cofactor for the microbe. And also we use inducer such as soybean hulls to increase the production of cellulase. So for the next one, we have the anti-foam. This is crucial so that we can control the foam in our bioreactor. Okay, for the last one, we have twin 80, which we use in the media to improve oxygen transfer into the microbe later on. Okay, that's all for my part. Now I will pass to Chashmita for her next part.
Thank you, Faja. I'm Shashmita. Now I'm about to explain about the process monitoring and control of cellulase production. The main objective is to maintain the optimal fermentation condition, maximize the cellulase production to ensure the stable and operation throughout the process. So cellulase is produced by the trichoderma vitae and in a stir tank bioreactor using a aerobic feed batch in the condition inside the bioreactor must be carefully controlled. So different sensors is very important to continuously monitor the parameters and the signals are sent to the PLC. The PLC compares the measure values with the set of the point automatically adjusts the equipment if it is needed. So at the same time, the SCADA system is also allowed operators to monitor the process in real time, record data, and detect any improve the abnormal conditions. So this is also improve the productivity and also maintain the consistent product quality. Next, moving to my next slide is instrumentation table. So this table shows the main process parameters is being monitored. So the first temperature is maintained between 20 degrees Celsius to 30 degrees Celsius using the RTD prop cooling jacket. So next, the pH is controlled between 4.8 to 5.5 using a pH prop with acid or sodium hydroxide dosing. So for dissolved oxygen, the level is keep above 30% saturation. If it automatically increase the agitation speed and airflow. Lastly, the agitation speed is maintained at 60 rpm using a variable speed motor to provide the good mixing and oxygen distribution. Thank you. Next, moving to my last slide of the instrumentation table. So the remaining parameters are also important. So next, the aeration rate. Aeration rate is maintained at 1.0 ppm to provide the enough sterile air for the microorganisms. So the foam sensor detects the excessive foam and automatically active the anti-foam pump. The liquid level is also controlled at 100 cubic meters using a level transmitter and the feed pump during the feed batch fermentation. Finally, the pressure maintained at 1 atmosphere using a pressure transmitter and also pressure relief valve to ensure the safe operations. So the conclusion is automatic monitoring and control also help the maintain the optimal fermentation conditions, and also it ensure the product quality and keep bioreactor operating safely. So thank you. That's all for me now.
Thank you, my friend Shashmita. Now I will continue to explain about contamination risk assessment and sterilization protocols for cellulose production in our bioreactor. In this process, contamination control is very important because trichoderma is sensitive to unwanted microorganisms, which can reduce production yield. Based on the table, the first contamination source is air inlet system, which has a high risk. This is due to possible HEPA filter failure or leakage in sterile air lines, allowing airborne microbes to enter the reactor. The second is feed and nutrient flows, also high risk because incomplete sterilization of media before feeding can introduce competitive microorganisms and affect enzyme production. Next, the internal surface such as impeller and vessel walls are a medium risk. Residual biomass and biofilm may build up after repeated batch, reducing oxygen transfer efficiency. Lastly, sensors and sampling ports are also medium risk because improper sealing and frequent opening may also cause microbial contamination in the sterile environment. Next, let's take a look at sterilization method, which are important to keep the bioreactor free from contamination. The first method is CIP, which stands for clean in place. This method means cleaning the equipment without taking it apart. First, water is used to remove leftover dirt. Then, a 1 to 2% NaO solution is used to remove organic waste like protein and cell debris. After that, an acid wash removes mineral deposit. Finally, sterile water is used to remove any remaining chemicals. Next is SIP, which stands for sterilization in place. This is done using steam at 121 Celsius and 105 kPa for 20 to 30 minutes. This step kills all microorganisms including bacteria, spores and fungi. So the system becomes fully sterile before starting the process. Lastly, sterile air filtration. A 0.22 micrometer filter is used to block microorganisms from entering with the air. It also helps provide clean air needed for aerobic process in cellulase production. In summary, this method help the system clean, prevent contamination, and ensure good product output. This concludes our presentation. Thank you for your attention.